Hi, folks. Thanks for being here in class. I'm going to kind of walk you through the steps of what I want you to do today. You should have just finished your warm-up and then also kind of figured everything out here. So let's go through, and I am going to just make sure we can do this right here. Okay? It'll take a moment for it to load here. But hopefully you've gotten to this point right here. We are going to talk first about, I'm going to see if it'll work in just a second here and go down here. The first thing we're going to talk about is this graphing polynomials. Okay, let's see if it works better here. There we go. Okay, so we're going to be graphing polynomials right here. Oh, so I ran into a problem. So I guess it's not going to be full screen. So you're going to use your calculator to create tables with x values from -2 to 2. And you're going to sketch a graph of each function. And those are the three functions we're going to use. And then you're going to make a table of the similarities and differences on the graphs. Okay? So this is how I want it to be in your notes. Okay? I want you to write in each of the equations. So you'll have A, take out your notebook right now, and on a fresh sheet of paper, write down the equations. So write down A, then write down B, then write down C. Then under each one, I want you to write a table of values, okay? Now, when you're making those table of values, put a table under each one, A, B, and C. Just x is from -2 to 2 for all of those. And then you'll find the values from your calculator. And then what I want you to do is once you've graphed it, put a sketch underneath it. So you'll have equation, table, and sketches. And then once you've done all three, you'll write down the similarities and differences. Okay? And then what I want you to do is stop at that point. So we'll stop the video right now. Okay, you're back here, hopefully, and I hope that your graphs look like this. The first one that you're going to have is as follows. It will look like this x minus 1 and x plus 1, okay? I hope you've noticed the graphs are looking kind of a little crazy, okay? It's kind of going up and down all over the spot. And I see that it's got an x-intercept. It looks like at -1, and then it looks like it's kind of going up and down at +1, okay? The next one, I'm going to see if I can get it to open up, folks. Nope. Okay, well, sorry about that. Chromebook errors. Okay, the next one I see looks like this. And this one's even more interesting. It has those two dip things at -1 and 1. And then the last one that I have, well, it looks like it's going up, it's going down. It looks like it has x-intercepts here, but I'm not exactly sure where they are. Okay? So when I think about some similarities and some differences between these two things, I think, okay, well, what's going on? So let's think about it. And why don't you stop right now and kind of talk to your neighbors about what you think. Okay, so I think that what I noticed was something about their ends. And I noticed right here on this one that one end went down and one went up, and it had 3 different x-intercepts, and the degree was 3. I know you think this is 2 right here, but we'll talk about why it's like that. I noticed on this one that both ends went up and it had a degree of 4. This is 2 x's and that's 2 x's. And I noticed that this one went up and this one went down, a degree of 5. So these are both odd numbers, but their ups and downs are different. So those are the things I noticed. If you didn't notice quite that much, that's okay. That's what we're going to talk about today. Okay, so we finished this activity right here. So let's stop. Make sure our calculators are put away and we're ready to take our notes. Okay, so hopefully you've made your stop right here, and I want to talk about what's going on next. And the next thing that I see happening is right here, your notes, okay? First off, I want to talk about something that's called end behavior. And the most basic odd degree polynomial that we can think of is y equals x. It's just a line. Odd degree polynomials will have ends that go up in opposite directions, one up and one down, okay? You're welcome to write this in, but I'm going to just have you listen. I'll show you exactly how I want your notes to be structured in just a moment. Likewise, even, the most even one I can think of is x squared, and even degree polynomials will have ends that go in the same direction, both up or down. But I want to do more than that. So let's really take out these notes right here and let's look at this. Okay? What I want you to do is I want you to have this as your title. I can identify the end behavior and orientation of a polynomial in order to make a sketch. And then I want you to, on the left-hand side, write even positive. And then I want some space. I know right here, oh, that's not what I wanted to have happen. So let's see if I can click back out. There we go. So I want you to make some space here though. And I know it doesn't show space here, but I want you to make some space for the orientation and behavior and example for all of these, because we are going to fill this in. I hope too that you're going to draw this line here as well. You're going to separate everything. I'm going to have you stop the video right now real quick so you can write this down. Okay, so hopefully you're back. You've written it all down. And now we're going to talk about this. This is our end behavior where it is and you hear me shuffling papers because I want to make sure I'm looking exactly like at what you have. But this is my end behavior right here, and I'm going to put this in my upper left-hand corner for even positive. Even degree polynomials with the following situations. If we have the orientation of a positive leading x term, these polynomials will go up on both sides. For example, this right here, this leading coefficient is positive, so both ends go up. We're also going to describe our end behavior. And you're going to want to memorize these end behaviors right here, okay? Because it's very important. It says, as x approaches negative infinity, f of x approaches infinity. That means when I start here at 0, if I'm going to the negative sign, my y values, or my f of x, are approaching the positives. Likewise, as x approaches infinity, so going to the right of 0, my f of x values are also positive. This is the exact end behavior I should see. Do not change this, okay? Take a moment, make sure you have this written down. Okay, the next one that I have is on the bottom left-hand side, and it is even degree polynomials with the orientation where we have a negative leading term, okay? And remember, when I'm looking for these even degree polynomials, we did this last week. We talked about how the biggest exponent here tells me that it is even. So 2, 4, 6, 8, those are even degree polynomials. So this one has a negative leading coefficient, okay? And so then my end behavior is the exact opposite. When I'm at 0, my x values, as I'm going further in the negative direction, my y values are negative. Likewise, as I'm going in the further positive values for x, my y value is negative. This is exactly how it should be. Please take a moment and write this down. Next, I'm going to go in my upper right-hand corner. This is an odd degree polynomials with orientation. And I don't think I actually said this, but when I have an example, I've drawn an example for you. Likewise here, I drew an example. So in the notes it said that. Okay, back here. This is an odd degree polynomials with a positive leading term. This is odd right here because the biggest degree is 3. The degree is 3. And a positive leading coefficient. So as x approaches negative infinity, I'm going towards the negative side, my y values are negative. Likewise, as x approaches positive infinity, my y values are positive. This is what my end behavior should look like. Stop for a moment and please write this down. Okay, the last page of notes that I have is right here. Orientation for odd degree polynomials with a negative leading x term. Positive side goes up, negative side will go down. Notice I've written negative side and positive side here, so I hope on the other slide you kind of wrote that down as well. Okay, so here we go. It's happening right here. Please take a moment and write this down. As x approaches negative infinity, sorry, I'm running out of time, folks, then it's going up. As x is approaching positive infinity, it's going down. Take a moment, stop the video, and write this down. Okay, that's all I have for you today. The rest of the stuff is on the PowerPoint. Thank you.